Okay, so today we're learning about limits. Okay, this is the basis of calculus. This is your first unit into calculus, and so hopefully by the end of today you'll understand the concept of what a limit is and convergence, and to use limit notation. Okay, so that's what we're talking about today. Now, pause the screen so you can write this down. But basically what this is saying is that this is the notation for what a limit is, okay? And it's read as the limit of Sn approaches infinity of u sub n equals L. In this case, u sub n is the sequence and L is the number the function, the sequence approaches as n approaches infinity, okay? So think about it. If you have a sequence, okay, such as 2, 1/2, sorry, that's not an actual sequence. 2, 1, 1/2, 1/4, so on and so on. Okay, you can see that as n approaches infinity, as your number of terms approaches infinity, this number is going to get really close to what number? Okay, that's what the limit is basically asking you to evaluate. As you look at this sequence, as you go from term to term, the closer that n gets to infinity, what number is it getting very close to? Okay. Now, a limit converges if the sequence approaches a specific number. So in this particular case, you can see, as I continue to go throughout my numbers, the next term would be 1/8, the next term after that would be 1/16, and so on and so on. Okay? It says, as the limit converges if the sequence approaches a specific number. So you can see that as we go through these numbers, it's getting closer and closer to what particular number. Think about it, it's getting closer to what particular number. It's getting closer to 0. Okay, so as the numbers continue to increase, it's approaching 0. So in this case, the limit is going to converge to a specific number of 0. A limit diverges if it doesn't. In other words, if it is approaching infinity, as the numbers increase throughout the sequence, as you go through the sequence of numbers, or it oscillates between two numbers. Oscillating means that it goes, say, 2, then -2, 2, then -2. Continuously, okay? In that case, there's no particular pattern, there's no particular sequence, just going back and forth between 2 and -2. All right? So if you look at these examples here, pause this video so you guys can get it down. We have to determine whether each sequence is convergent or divergent. Now, if you think back to when we were doing sequences in series, if R, the absolute value of R, was less than 1, then the series converged, okay? So keep that in mind. In this case, if you look and think about the next terms in the sequence, it's going to be 0.33333 5 times. The next one is going to be 0.3 6 times. And it's going to keep on going. And so in this case, it's getting closer and closer to 1/3. So the limit as n approaches infinity of this particular sequence is going to be 1/3. So yes, this one is going to converge. All right, the next one, R is going to be 2, because you're multiplying by 2 each time. In this case, it's going to diverge. Here, look at this one. If you can't figure this one out, convert it into decimals. This one's 0.2. What is this as a decimal? What is this? And you'll see that this one is actually getting really close to 1/4. So the limit as n approaches infinity is going to be 1/4, and so this one converges. And the last one you see is oscillating, so this one is going to diverge.